Welcome to today's webinar on 4 ways to achieve sustainable manufacturing. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I will be moderating today's webinar. Presenting today is Tim Mao, our Applications and Technical Support Manager. A few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. I'll be monitoring the questions, and at the end of the webinar, we will have time for a short Q&A session. Finally, this webinar will be recorded, and you will receive a link so that you can review the webinar at your convenience. With that, I will now turn it over to Tim Mao to kick things off.
Thank you, Robert, and good morning, good afternoon, good evening, depending on where you happen to be connecting from. Thank you for joining us today as we talk about 4 ways to achieve sustainable manufacturing. Let me launch into this and we will proceed. So, first of all, what we're gonna talk about today, hopefully what you will learn coming out of this webinar, why establishing appropriate tolerancing is important. What are the benefits of the various instruments and software that you can use to help us essentially reducing waste, being more efficient, more sustainable in what we're producing. Why is digitizing standards going to help you here with a sustainable workflow, and how can we even virtually examine materials? And so we will touch on each of those topics as we go forward. So first, we're going to talk about how we ensure colors on target before a run is wasted. Obviously, reducing waste is a huge need for all of us. It's something we all are working at, and so establishing color tolerances is a part of that. Color accounts for 60% of acceptance or rejection in production. And if you set your tolerances too loose, obviously might make you feel good, but it might mean that you're producing unacceptable samples, which ultimately your customer may reject. And of course, if we set the tolerances too tight, it increases our cost. It increases all of the usage of materials and energy that we have, as well as we may have acceptable samples that will fail. So we would essentially turn them into waste when they aren't really. This graphic with the red and the green squares and the black ellipse is kind of a help us think about that. If the black ellipse is what's visually acceptable, I can create a tolerance if my tolerancing is square that's like red to make sure everything that's visually good passes, but it means all the area of red that I see is an area where I'm going to be passing unacceptable samples. Or I could make that square tolerance the green one to make sure that I never pass anything that's not good, but it means now I'm rejecting things that are. So we need to be careful about how we set the tolerancing. It's critical that it be something that we can achieve, that's agreed to by the customer, and can help us control our costs and our waste production. To do that, we need to be able to take measurements, and there's a number of different ways we can do that. One is with a handheld spectrophotometer, and the biggest advantage that a handheld instrument is I can bring the measurement device to the part that needs to be measured rather than always having to bring the part to the device. It's portable. I can bring it where it needs to be. It's ideal for an uneven or even hard to reach surfaces, right? If I need to measure something concave or convex or oddly shaped, a handheld instrument can help me get to those things more easily. And I also have the ability to store things, for example, my standards, and take a measurement. And as you can see on the screen of that instrument, there's a red bar with an X on it at the top, telling me that the sample I just measured did not pass my tolerance. So the speed with which I can determine whether or not my color is acceptable or not stops me from continuing to manufacture potentially product that is out of spec coloristically. Benchtop spectrophotometers also play a role here. Extreme high precision and accuracy from a benchtop type instrument. More repeatable or actually even tighter inter-instrument agreement. So if I have to do measurements and compare them with another location within my workflow or my supply chain, having a benchtop instrument helps me ensure that the numbers I get will be the numbers that you get if we both take measurements. And a benchtop even allows me to do things like measuring a transmissive sample or do UV calibration if I need to, or some extended wavelength measurements where I'm getting below and above the standard visual wavelengths of 400 to 700 nanometers. So benchtop instrument for the high-end, high-precision needs, it may be necessary to help us here. We also have instruments to consider that are non-contact. So I'm able to measure a product without actually touching it. That can eliminate sample distortion. If the sample I'm measuring is molded plastic, let's say, as an example, and it's fairly thin, it's really easy in using a sample arm or a handheld instrument where I'm pressing down on it to take a measurement to distort the sample, where a non-contact instrument, completely non-destructive, completely removes that distortion issue that could exist. We have the ability to measure wet samples. Again, a time issue, right? Sustainable manufacturing and reducing waste can be greatly improved by allowing us to more quickly determine when we have color issues. So if we can do that by measuring a wet sample prior to having to wait for dry times or whatever, we can again speed up the time for us to detect issues and correct them. And we can measure odd-shaped samples and so forth with a handheld, or I'm sorry, with a non-contact instrument. So we're going to ask you a poll question here for a few seconds. So Robert will open that. Give you a few seconds to answer that. All right, let's move on. So we've got an instrument, and maybe we've got a mixture of them in our workflow. So we need to also make sure that our instrumentation is performing properly to ensure it's not going to contribute to any variations in color that we have. So to validate and even profile our instruments, they'll allow us to reduce waste and error caused by measurement drift. And many of these can be corrected by profiling our instrument. And this product called Net Profiler enables standardization of color criteria across locations. So as an example, let's assume we've got 3 different locations measuring color, a benchtop and several handhelds. And the agreement between those instruments over time will start to, when we first manufacture them, of course, they're very, very close, but those instruments are in different environments, exposed to different amounts of different temperature and humidity, amounts of humidity and dust and usage and lamp life, and all those kinds of things contribute. But Net Profiler allows us to take those instruments and essentially mathematically correct them all back to measuring as close to the centroid as possible. So instead of a population like this, where you can see that different instruments may be contributing to some different results, we get this, where they are essentially overlaid on one another to ensure that the amount of difference between the instruments, were I to take the exact same sample and measure it with all of them, is negated greatly. So that's about the measurement part of it and the instruments. Let's talk about control at all stages of the manufacturing process. So we begin by talking about formulation software. Software that will allow us to generate a recipe, right? Just like just like you might have a recipe to bake a cake, we can have a recipe for a color that tells us the specific base to start with and which colors to include at what ratios and percentages, right? Doing that will reduce the time and cost, because we're not just measuring, or we're not just matching color three-dimensionally in an LAB kind of sense, or the way that a color matcher does it by eye. You look at it and it's you know, some knowledge in the color matcher's head that helps you to say how light or dark is that color, is it red, is it green, how saturated is it, and so forth. But we're doing spectral matching that reflectance curve you see down there in red on the chart. All right, we're actually going to try and match the curve when we do this. And when we do make a batch, so let's say we're making paint, right? And we just made a 500-gallon batch of this paint, but the color's not exactly right. Software also has the ability to calculate, recalculate, or calculate an add, we would call it, to correct that batch so that the color's not wrong, and bring that color back to something that we can sell and is not waste. But ultimately, there are times when we end up with waste. I worked in a paint company years and years ago, and know from my own experience, sometimes somebody misreads something, and they were supposed to put in 0.5 pounds of black, and they put in 5 pounds of black. Well, that color is now so far gone, you'll never get it back. So now I have 500 gallons of paint the wrong color. That's waste. Now, maybe I can sell it at a really discounted price to somebody who just doesn't really care about the color. But what if I have the ability to, with a piece of software, take that a measured sample of that color, that waste color, if you will, and use it to mix with other things to make another color. So maybe the amount of black I put in there made my color too dark for what I was trying to match, but a week from now, I may be making a color that's even darker than that, where I could use this waste material and turn it from being waste, which we all want to avoid, right? Because we either have to sell it at a discount, or if it's truly waste and we have to try and dispose of it, all kinds of environmental problems and costs and everything. Instead, we were going to turn that into something that's actually sellable. So that's a really important feature that we can do with formulation software. Quality assurance software allows us to validate the color throughout the production process to ensure we're achieving the best possible color. Again, we're able to measure, we're able to detect color changing over time. We don't have a trend chart up here, but you can imagine we had a trend chart as if we're taking measurements throughout a production run. If something is changing over time, we will see that, and we can detect it before it becomes a problem. You'll notice in here our software has green check marks and red X's. We also will put in what's called a warning level. So a green check mark means it's within your tolerance. A red X means it's outside the tolerance. But we can put a warning level in so that as you start to approach a failing state, the software is warning you, oh, you're starting to move toward a failure. It's time to fix something before I get to that point. So again, catching an error before it actually happens. We have the ability then to enable an audit trail to track the color of something. Should there be an issue with it down the road, right? From a customer perspective, and those kinds of things. And all of the supporting data. Not only are we capturing color data here, but we have the ability to capture all kinds of other things. The user can input things. The software can communicate and output its data directly to a database that maybe your ERP and order system is managing. So it's connecting everything together to ensure true traceability of your production. So item 3, we want to talk about taking the subjectivity out of color communication. So we're going to ask you another poll question here about what kind or types of standards you are working with, and the poll question will lead you down the path there of what we mean by types of standards. So if you don't mind, take a moment or two and look at that poll question and respond for us. All right, thank you for doing that. So moving forward, we're going to talk about digitizing standards. Visual assessments require time, obviously, and they also require the material, right? Physical material has to be present for you to have the ability to do an assessment. The alternative to that is, of course, a digital standard. And one of the, there's a number of issues with physical standards. We'll say this, but I will also tell you that ultimately, right, visual is where everything comes to. Mostly because we all go to a store and we make a purchase decision based on what we see. But if we can reduce the amount of visual assessments that need to take place, for example, some of you probably encounter this on a daily or weekly basis where you need a visual assessment of a color. And in order to do that, it means a sample goes into a FedEx envelope or some overnight delivery service or DHL or whatever, right, to send a sample from point A to point B. And maybe that's across the city, across the state, across the country, or around the world. There's lots and lots of samples flying back and forth and all of that. We're not saying we can completely eliminate that, but if we reduce the number of times that has to happen, every time that happens, there's the consumption of all of the energy and effort to actually move that sample, but there's also the consumption of your time waiting for the sample to arrive to be able to say yay or nay. And what we're talking about in digitizing standards is about having the spectral data of that standard stored so that I can compare to it no matter where I am. One of the other issues with a physical standard, and one of the reasons that people have to send samples around, is we also don't always have the physical standard anymore, or maybe we have a very limited access to it, because if I'm going to specify a specific color, I don't necessarily want this, and I have this one swatch or chip or drawdown of this color. I'm not willing to send that around to everybody because it's going to degrade over time and use, and then I don't have a physical standard anymore. So digitizing that standard stores it in perpetuity and allows us to do comparisons to it globally. So digital standards also remove some subjectivity that happens and ultimately are saving us time and reducing waste. To expand on the digital standards, we're going to talk about this thing called Pantone Live. And Pantone Live, those of you who are familiar with the Pantone part of our company, is color standards. And Pantone produces colors that are printed on paper, that are fabric, that are plastic, that are paint, all of those different things. And with Pantone Live, we now get into an even broader range of digitizing standards that can help us reduce waste and the error stack. So it goes all the way back to the designer. So the designer could have access to Pantone Live, and in his design world, whatever design tool he's working in, he could be specifying, working with the brand or the specifier. They're going to identify the color they want to use. They can pick that color in their design work so that their assessment and work in design is using the exact same color standard that ultimately is going to get passed on and approved by the specifier, going kind of clockwise around this circle. And then the color producer, right, is going to use that same digital standard to formulate to. And then the manufacturing locations are both manufacturing to the same colors, so that ultimately we get back to a specifier or a customer who gets what he wanted you ask the designer for something, the designer designed it, and the color remained constant throughout. Pantone Live allows us to do that so that the designer, as an example, is designing it with a plastic Pantone color or a textile Pantone color that's predefined, and now everybody's hitting the same thing. So we don't have this color shift or an error stack that occurs as we move around the circle. That allows people to be very, very consistent in the color throughout the process and avoid the, manufacturing, this is what you produced, it looks good, but it's not exactly what we were looking for in design, and it helps to reduce and eliminate that problem. So lastly, we're going to talk a bit about the ability to virtually examine materials without a physical prototype. And I'm going to talk here quickly about a new line of products that we have called Total Appearance Capture. So the first thing we see here that's called Capture is a product called the TAC 7. It is essentially, as you can kind of see, it looks a bit curved. It's like a half a dome, if you will. And a sample goes inside of there. Let's say it's a piece of leather, right? We put the sample inside, and this device is going to scan that from all kinds of different angles to capture, hence its name, to capture all of the color characteristics of that. But it's also going to capture, excuse me a moment. Sorry about that, I had a cough. It's also going to capture its appearance characteristics, meaning things like its texture, its translucency. If I were to scan a piece of fabric, you know how a piece of fabric has a weave and it has, hills and valleys and all those kinds of things and shadows. And we're not only going to capture the color, we're going to capture the entire appearance of that. That then goes into a piece of software where we can take all of these slices of data, all this information about this product, to manage it. Our software then creates something called an AXF, which stands for Appearance Exchange Format. And we can then take that and digitize it and show it in this product, which is called a VLB, Virtual Light Booth. So this is a light booth. Those of you who have seen an X-Rite light booth before, it's the same, except in this one, the back wall of that light booth is not actually a wall. It's a very high resolution monitor. And so it allows us to project, in this particular snapshot in the back left, that's a digitized 3D version of a color. And in the upper right part of that, that's the physical sample actually laying there. So I can look at physical versus virtual color. And then that file, that AXF file, goes into all of these third-party 3D design studios, and many more of them actually. It's growing every week or every month. There's more and more. So that a three-dimensional virtual image is created that allows us to see color and appearance and so forth. So as an example, seeing a product, whatever that product might be, can be produced and shown virtually, and then we can simply pick a different scanned color, let's say a different color of leather, or I want to see something, what does it look like with brown leather on? How does it look like, what does it look like if I put this color of patterned fabric on it, or what does it look like? And we've seen, one of the examples we use here in our lab is a tennis shoe, where we've actually recreated it, and you can change the color of all the different components on that shoe. And so virtual product design, if you will, that allows us to very quickly predict or show a virtual representation of what that color and what the appearance of that would be. And of course, we can rotate it and do all those things, and we've captured all that information to allow us to very accurately reproduce that. So these systems are becoming is relatively new product for us. It's been around for a couple of years, but it's exciting because it's moved us past just color. And I don't mean just color to sound degrading to the measurement of color. It's still critical. It's still part of this, but we're adding those other attributes. Any of you who have done color comparison for any time, you've seen those colors where you say, yeah, the two colors measure as the same color, or very, very close, but they look different. And oftentimes, that's because there's an appearance difference in them, meaning something different in the surface rather than the actual coloring of the material. So here we're starting to capture all of that. All right, we're through all of the slides and the information that I had to share with you. So at this point, we're gonna open it up. Robert will grab any questions you may have, and we'll try to answer them the best we can.
Yep. If you haven't submitted one yet, please go ahead. It looks like we already have a few questions that came in. So the first question is in regards to the QA software and seeing color change across a production process. Is there a way to actually visualize this in a graph within the software?
Yes, there is. So the software, in our screen grab, we didn't happen to show it, but you can actually plot a trend where and across the horizontal axis going from left to right would be time. So let's say I took 20 measurements of a production run. I'd have 20 dots across this trend chart. And maybe I'm going to I could plot my delta E that I'm tracking, maybe my delta E 2000 or whatever, or I could plot the lightness, right? The chroma, the hue, the LAB, whatever values that I can display in the software, pretty much I can trend. And then it'll actually show me over time, is my production, if I'm plotting lightness, let's say, because that's the easy one to understand, is it slowly getting lighter and lighter? Is it getting darker and darker? Is it kind of bouncing around and being pretty consistent? Do I see a trend of color shifting in one direction or another? So it's entirely possible to plot those things in the software. It's just a setting in the software to do that. So if you're a user of IQC and you want help with that, you can reach out to us. The phone number that's on the screen right now. In fact, if you call there and just go to the tech support team, they can easily help you create a trend chart to allow you to do that.
Next question is about virtual light booth. What's the difference between looking at a physical sample in a light box and looking at the sample developed inside the virtual light booth? I think they just probably want some more clarification on that. Sure. So obviously there's an issue, right? With the issue of looking at something digital versus real. We've all done the take a picture of something and then look at it on the screen of your phone or the screen of your computer, if that's where the picture is, and it doesn't look exactly the same as what you see when you look at the actual object. Part of that is because we're dealing with a photograph, which is very similar to taking color measurement, right? It's looking at the reflection of light off of that in a single layer, if you will. What the TAC scanner does is it allows us to capture so many more things so that we can, about its appearance and the various layers, if you will, that are there, to allow us to accurately reflect it digitally. And what I mean by that is, if you just think about I keep going back to a piece of leather, but I'll use that as an example. If you take a piece of leather and you bend it, it doesn't look like a solid color anymore. You see different colors, and I'm not talking about creasing it, just even a curved bend to it. You'll see that leather has a variety of colors across it that vary more as you bend it further and so forth.
because of how we've captured this, we have the ability then to digitally reproduce that. And so that's what allows the virtual light booth. And keep in mind, virtual light booth is nothing more than a demonstration of, we've scanned this product, this fabric, this leather, whatever, right? It can be car paint, could be plastic, could be any substance, right? We've scanned this particular material, and now we can accurately reproduce it, not only what it looks like at one specific angle, but at any angle, and I can change where the light's coming from, and it will accurately show me all of that. So that's the part that typically gets in the way of us seeing something digital versus something real. That lack of the ability to automatically adapt or to understand the color and the appearance properly, to adapt to the perception and changes that happen due to viewing angles and lighting and so forth. It's kind of like, animation keeps getting better and better, but there's always, if you look really close, you can always tell something animated from something real. While it's getting better and better, right? A lot of what's produced by Hollywood these days is we might think is actually happening with real people or real objects, but aren't. They're computer generated, and some of it is this ability to be better and better at reproducing that. So virtual light booth is just a great way to say, yes, the digital thing does really look like the visual thing. Unfortunately, in a webinar, this is really hard to talk about and demonstrate. It's one of those things that if you ever have the opportunity to come to X-Rite, or you see us at a trade show somewhere where we have this information, or I'd even encourage you to go to our website, because there's some video available there that will demonstrate how this system works, and it's really quite remarkable in how it can produce a digitized version of something.
Great. It looks like that was actually the last question, so that marks the end of this webinar. You will receive an email with a link to the recording of this webinar and additional resources. I just want to say thanks for joining and have a great day.
Thank you, everyone.